This is Ray's OU or over unit experiment. You can do number 3. I have set up here a small car. It has a clay base. It makes your mounting easier. I have a pack of 10 neo-magnets, 1/8 by 1/2 inch each. There are 2 metal bars. They are 3/8 inch square by 1 inch. We're going to be showing that there is a torque produced when a magnet comes into the field, which we are going to put together here. It's starting to do it on its own. So we have our magnet pack. We'll place that on our clay mount. Our car, our magnetic car, can move freely. We'll demonstrate as we bring in our magnet from the top at a perpendicular fashion that there is a torquing force produced. We will discover later that there is less force input required to bring the magnet into place than the force torque that is brought as an output. So my definition of an OU or an over unity effect is that there's more output than there is input. That's my definition. You can set this up pretty easily yourself. And if you want to go the other direction, turn your magnet around. It'll spin the other opposite direction. And it's a pretty good strong force compared to the input force. Okay, this is part 1. This is part 2. We have the bar that the placement would have been on the small car, the bottom. I have placed a dowel rod, wooden dowel rod, to keep it into the position in which we demonstrated it, part 1. This would be the arm coming down, or your magnet into the input. So I have an ounce meter gauge. It shows the ounces. So I will bring the bar down into the position for firing, and we will see what that is. I have it on a cam shaft back here, and that'll kind of stick sometimes, but when it's running it does not. Okay, we'll go ahead and show the measurement. Okay, we're going to go down till we hit. Okay, we're hitting the bottom. do that again. Placement there. Get a close-up view. Okay, here we go down. Till it hits bottom. So we can see that there is very, very little input power that's needed to activate the magnet. One more time. Down. And bottom. So we'll go ahead and set up, we'll measure the torque power. This is part 3. I've removed the dowel rod. It is now as it would be after it has fired. What we want to measure is the torque that is present. So in order to do that, I'll take my ounce device and I will bring the torque backwards and I will measure the torque needed to bring it back into the first position when we were firing. Okay, that's what I'm going to be doing. About 4. Push it back. Okay. So what we're doing is, this is the fire position. We're measuring from the initial setup on the little car, where we're bringing down the top magnet into the field of the second magnet where the car is. And this would be the torque that's spinning the car. So when you do the experiment, you'll be able to watch this. So let's go ahead and measure that. And again, I'll be bringing it back around like that. Hold this still. Here's about 4 ounces. So that is the ratio between in and out. More power out in the torque than the power needed to bring in the magnet. So when you do the experiment, this is what you'll be doing and experiencing. I'll go ahead and start my machine up. I've also made a video, Ray's magnetic field shaping generator number 4. You can watch that. This would be your handheld magnet. This would be the assembly on your car. And to see the torquing capability, these are my LEDs, and I have 45 individual LEDs. They're not maximum brightness, but they are firing. Thank you so much. There again, just to recap, we have a very low input force, and we're creating a larger torquing, and the numbers were, the torquing was somewhere around 4 ounces, and I chose that spot for my gauge, my ounce gauge, because that's where the concentration of the magnetic forces were, just on the outside of those magnets, so that's why I chose that. And the input handheld magnet, we could see from the ounce gauge, was just almost nothing. So the ratio, it's your guess as good as mine, and you can make up your own decision, but it's a lot of fun. I enjoy and am fascinated every time I put together the little car and demonstrate it. So hope you have fun. Have a good day inventing. We'll see you next time.